So in this lesson here, we're going to work on calculating exponential growth. So there's a formula for exponential growth, and we'll get to that in a moment. But we're going to go through a couple problems here together. So our first problem that we have is Carlos is doing a study of fruit flies in his science class. He observes that the number of fruit flies doubles each day. So that's an important piece of information, I think. So I'm going to go ahead and underline that. And then it says on Wednesday there's 24 fruit flies. That also seems pretty important in the enclosure. And we're going to write a formula to calculate the number of fruit flies. So I need to write a formula, so I'm going to go ahead and circle that, so that way I know what I'm trying to do here. Now, the amount of fruit flies I can see here is going to be the variable f, and a day is going to be variable d. So when I'm writing formulas for something that's going to be multiplied again and again, we can use our geometric sequences. We've already learned a little bit about that, so let's go ahead and use that formula. So the formula for calculating a geometric sequence is a sub n is equal to a sub 1 times our common multiplier, or common ratio, raised to the power of n minus 1. So just like when we're working with geometric sequences, we're going to substitute a few things in. So let's go ahead and think about what this is actually figuring out. So our common multiplier, our r, our common multiplier here is the thing that's going to happen on a daily basis or on a yearly basis or based on some sort of interval that's defined in our problem. So it says here that it doubles each day, which means I'm going to be multiplying by 2 each day. If I have 5 of something one day and it doubles, multiply that by 2, it's going to be 10. So my r value here, my constant ratio, is going to be 2. And then when we had a sub 1, a sub n, and then n minus 1 in our geometric sequences, what those represented were certain numbers in our sequence. So I know that a sub 1 was my first number in my sequence. And I can see here that it says Wednesday there's 24 fruit flies. I don't really have any other information, so I just need to base that off of that being number 1. So I'm going to use 24 in place of a sub 1. And then I know that n in my geometric sequence referenced the number of this term in the sequence. So the first term, for instance, would be a sub 1. That 1 is my n value. So that's going to be my d. So in place of n, I'm going to say d minus 1. And then my a sub n is going to be the number of fruit flies. So the number of fruit flies are the items in my sequence. As the number of fruit flies increase, that's going to be my sequence as it goes along. So I'm going to have the formula f is equal to 24 times 2 raised to the d minus 1.